and Mercy, and we did our project on an automatic hand sanitizer dispenser. Next slide, please. So the purpose is to have this hand sanitizers hands-free by utilizing a sensor that will sense your hands, so you could avoid touching the item itself, unlike using a bottled hand sanitizer by squeezing it, or like when you have to press the pump. So with that, it can minimize the amount of physical contact. And while the virus is still going around, with this, it will be more safe and easy to access as well. So with the size of it as well, it will be portable, so you can put it in a spot where it'll be more convenient for you to use, and as well as being universal with any sanitizer. And hopefully it encourages more people to be more sanitary. Next slide, please.
Okay, hi everyone, this is Mercy. The electrical design has three major parts: the sensor, the the signal conditioning and controlling part, and the actuator. And the whole system is powered from a 5-volt USB cable. First, the sensor. So for this project, the sensor we used is the IR proximity sensor. As you can see from the picture here, the IR sensors have two LEDs. One is the emitter that emits the infrared ray, and the other is the receiver. So how it works is when there is no object presence, there is no IR light detected. But when there is an object present, the IR light gets reflected upon the object and gets received by the other LED or the receiver. And when an object gets detected, the sensor gives a 5-volt output voltage signal. So on the opposite side of the LEDs, we can see that there are 3 pins labeled as VCC, GND or ground, and the out pin. Next slide, please. So here in the wiring diagram, we see that the VCC and ground pins are connected to the 5-volt and ground terminals of the USB, which is just red wiring, and this black one, which is the ground. And the out pin is connected to the base of the transistor through a resistor, which this is the green wiring. So the question is, why can't we just directly connect the sensor with the pump? There are two problems. The sensor's digital output can only handle few amps of current, and direct connection with the pump damages the sensor. And second, the IR sensor has a default digital high output, which means it has a digital low output when detecting an object. So for the dispenser to work properly, we need a logical inverter or a switching device, and both problems can be solved using a PNP transistor. The output voltage from the sensor will be fed to the transistor base through a resistor to produce a suitable base current to the transistor. Previous slide, please. Previous slide, please. Yeah, thank you. The PNP transistor sources the PNP transistor sources the positive voltage. Once we give a 0 voltage to the base of the transistor, which is when the sensor gives a low digital output, then the transistor is activated, and the positive voltage will be provided through the collector side of the transistor to the load. So the collector terminal of the transistor is connected to the third main component of our system, which is the water pump. This pump has an electrical motor that converts electrical energy to mechanical energy, which in turn is used to move or pump water. The current that drives the motor is fed from the transistor. So whenever the transistor is switched on, the pump will start pumping the sanitizer. Next slide, please. For our project, we use a Protus circuit simulation software to construct our circuit and run a simulation to check its operation. So by default, the sensor is a high when there is no object detected. So it's 1. So when a hand is detected, the sensor will give a digital output and the pump turns on. Yeah, so this is all the electrical design. Thank you.
All right. Hello, my name is Arwen, and I'll be talking about the structural design of the project. So, when designing the project, we wanted to consider the fact that we wanted to make the dispenser portable in the first place. So, one of the limitations that comes with that is that it needs to be a little smaller, so it's more convenient to carry around or place in other areas. And this created limited space on the housing or the container to put all the electrical stuff and just to work with in general. And some other things we needed to consider was the possibility that it would be like imbalanced. It would like maybe topple over because there'd be a lot of weight on one side as opposed to another. We had to consider short circuiting because we are working with liquids in the first place with electrical and they don't really mix well. And we also had to consider it with sensor blocking. We used a submersible DC water pump connected by a 4x7 millimeter tube, and this served as a path for the sanitizer to go through to actually dispense. And we used chicken wire placed inside of the tube for added stability. To refill the dispenser, it's very easy. You just twist the cap off, twist back on. Very simple, very convenient way to refill. And we put the electrical components on top of the lid in order to avoid any malfunctioning. Like I said, avoid any of the sanitizer dripping onto the electrical components.
Okay, so for the materials, there are quite a few number of materials that we had to use. So for the housing, it was actually materials that I found lying around the house that I could just reuse. So for instance, like the plastic container, and the chicken wire, the silicon tube I had to purchase, and then the tools for soldering. I had to use things like wire cutters just to strip like the wires from like the outer layer of the wires to get access to the copper portion, and just all the general tools that I used throughout the soldering process, such as the wire, the flux we used to clean, the soldering iron itself, and the steel wool, and just all the components that ended up getting soldered together, which was the IR sensor, the transistor, resistor, the DC motor pump, the UC cable, and an individual little jumper wire. So for the assembly, there were two parts that got soldered together, the IR sensor and the transistor. In the IR sensor, the ground pin got soldered to the ground wire, the DC motor, and the USB cord, and the VCC pin were wired to the positive wire of the USB cord. And for those two, they're going to be providing the power whenever it's plugged in. And the out pin is just going to be sending out the signal from the resistor to the transistor. And from the transistor, the B, which is the base, is just going to be receiving the signal from the out pin of the sensor. The C pin, the collector, is just it's also going to be providing power from the motor, and the E pin, just the emitter, is just going to be the individual jumper wire, just connecting the VCC pin of the sensor to the transistor itself. And so for testing, since this was a DC motor pump, it was obvious that it was going to work with water. So I just did a quick test just to make sure that all the soldering worked properly and that the device connected to the power when it was plugged in, and that it brought in the water in and out. And I'll show you here in the video. And then when I tried out the gel, because that was the one thing that I was a little more curious about, which turned out to be a failure, because it turned out that the motor wasn't strong enough to be able to pump the gel through up into the wire. In fact, it never even reached halfway through the tube, or I don't even think it barely made it past the motor itself. And in order to like kind of clear the motor out of any like gel that got stuck, I just had to put it back into the water, and it just pushed it all out. And here's a demonstration of the gel. Oh, oops, that was my bad. And just a quick note, if you notice in the previous video, in the background, you can hear the motor. It was running, it was doing a quick noise. And in this one, you will barely hear a very faint noise when I put my finger in front of the sensor. And yeah. Yeah.
All right, so in the financial breakdown, as you can see, the project was rather inexpensive. It was fairly cheap. Like the total of everything was around $32. And as you can see, the most expensive, like singular piece of this project was the submersible water pump, which was like $7. So some of the challenges that we faced during the project was it was Daniel's first time soldering, so I can imagine it was like a learning process for him to try to get everything right and working properly and not make too many mistakes. And something that happened during testing outside was that the wind was interfering with the IR sensor. So most of our testing was done indoors in order to prevent any unwanted like activations of the pump. And for the results, we kind of came to the conclusion that the motor that we were using was not strong enough for to dispense the gel sanitizer, and that the dispenser really only worked with the liquid sanitizer or a combination of the liquid and the gel.
So here we have our schedule of a PERT chart. As you can see, we first started off researching and brainstorming on the design, which consists of the materials needed, the electrical design and the mechanical design. Once we were able to figure out the design, we were able to work on the electrical and then the mechanical components when the materials arrive. Afterwards, we can assemble all the components together for a appropriate and proper fitting of the build, and then test for its functionality and its liquid and gel sanitizers. So we were able to finish this on time, along with doing the final report. Next slide, please. So in the end, the build was successful in some way, as it was functional, working with the liquid hand sanitizers, except for the gel. So it didn't meet all expectations. And we did encounter a few errors, but we were able to handle them properly. And while this project was like budget friendly, it is practical to use because you will be able to avoid touching the product itself, as well as bring it with you anywhere convenient, as like putting it in your car or on your desk. So we hope to recommend that for a better functionality, to use better equipment and to use our time